Good morning, everybody. My name's Jason Fox, and I am the Senior Technical Evangelist at the FIWARE Foundation. And the subject of today's Wednesday webinar is how to debug IoT agents, or rather, more generically, how to get your data from whatever your system is into the context data layer and potentially up through to processing or further details. So let's see what we're going to learn today. The learning goals for this session are as follows. First, we're going to see how to diagnose some common problems and be able to test our services within isolation. The idea being that when it doesn't work, you need to be able to cut your problem down to smaller issues so that you can work out which layer isn't working. We need to be able to set up and interpret the debug from the various disparate elements of the FIWARE ecosystem, which, because they are contributed from multiple sources, are not consistent with each other necessarily. We're going to ensure that you know how to configure your IoT agents and where you need to set these things up and where these things are actually defined, so you can work out what the setting needs to be. And equally, there are various different layers at which they can be overridden. So you need to know the order at which things overwrite other things. If necessary, it is possible to add things like diagnostic debug, and perhaps most importantly, if after you've tried all these things and it's still not working for you, where to look for help and advice from other members of the FIWARE community. Just to recap, we're dealing mainly with the interface between the box at the bottom, which is where your senses the real world or your robots or whatever, then connect up to your context broker, and thereafterwards potentially you could get into the processing layer as well, but obviously the data will need to flow from the context data management layer out into the real out into your application in order to do something clever. So it's a very, very common and generic problem which everybody will need to cover based on whatever their devices are or their sensors are, what they're talking about, and so on and so forth. The scenario which we're going to deal with as a very simple example is just purely taking some information from our devices, using an IoT agent to receive data using some common protocol. It really doesn't matter because the steps for debugging this system will be the same. Obviously, the actual details will differ depending on which IoT agent you're using, but the overall strategy will remain the same. The IoT agent obviously receives something in some proprietary format and therefore must then interpret the data and create NGSI data entities within the context broker. And at some point, you've got to get your data out of the context data management layer, and therefore the system will need to react on changes in state somehow. In this particular example, it's going to be quite simple. We're just going to put some data into a database using Cygnus, but it could just equally be getting a dashboard going or doing some complex event processing or whatever, or it could be your own module which is listening in for a subscription. It doesn't really matter at all. It's just that we need to make sure that everything is flowing, in this case, from the bottom of the screen all the way up to the top. In a working system, you may also add more complexity, such as changing the transport, say using MQTT or AMQP or T or whatever it is, and or adding in additional security. Each one of these is going to add in more potential problems which you will need to overcome when you're trying to work out what's going wrong. So what can possibly go wrong? What can possibly go wrong? You could quite easily be listening for data in the wrong place. You could be listening on the wrong port. You could be listening on the wrong resource path. You could be setting up your IoT agents to listen on MQTT, but actually be sending data on HTTP. You need to make sure you can get the configuration in the right format. You could be failing to pay attention to the FIWARE service headers. We'll come to that later on, but because the data is potentially split amongst multiple databases, you can pass data into your system and then find that it's not where you think it is, it's somewhere else, you could quite easily be misinterpreting the information received. This is particularly the case if you have a subscription with a greater than. You could be reading your numbers as strings, which could make things difficult. If you are using Docker for your system, then it is possible you could do things like setting up a subscription using localhost, where localhost inside the containerized environment is not the same as what you think it is on your actual machine. You could be setting up the subscription so that they never fire, so you get no data coming through. And in general, you could be failing to provision your services and devices correctly so that the system is doing what you expect. So you need to be able to read the config files to work out this is what the base default is, and therefore this is how I need to override things. There are also a couple of other less likely scenarios. You could possibly be using an old system using NGSI v1, and the documentation is saying NGSI v2. That could cause you issues, and you could possibly be using a combination of versions of generic enablers which don't work with each other. Again, I'll explain how to avoid going through all of these pitfalls. I think over the last 12 months, I have probably done all of these, and I've also diagnosed where I've gone wrong. So if you're listening in now, it will probably save you a lot of time to work out what you should be doing. So the way that you set up an IoT agent in the lowest level is within the config.js file. The config.js file, if you're doing it within a Dockerized environment, config.js file is part of the files which get into the Docker container, which has got a series of default values for various different things. You can see here, for example, that by default, the value for the MQTT is on port 1883, and so on and so forth. You can see that each of these elements are highly annotated because it explains what everything is. This is probably the first level of documentation you would look at in any IoT agent. It says what the various things are, but a large number of the more higher level elements are actually switched off. They're commented out. So, for example, it's not set up using usernames and passwords. It's not set up using security and so on and so forth. So it may well be the case that your initial setup is not the way you want it to be, but this is the situation you will have unless you either inject a different config.js or you use Docker. Now, if you use Docker, you could inject your own volume, your very own config.js file, and then modify that directly. But perhaps more frequently, you'll use something like Docker Compose, and then add in a series of environment variables. The point about the environment variables is that each of these values here overrides the values which are in the file, the config.js file itself. Now, for example, this is saying that we must be using NGSI v2, and we will attempt to send our numbers numbers as numbers rather than numbers as strings. The actual elements values you can change will vary between your various agents. If you look at the documentation for the various agents, if I go in here, the base information, which is common to all IoT agents, can be found in the IoT agent node lib documentation. And these are common things like common password, or which port you're using for authorization, and so on and so forth. You can see there's quite a long list where your MongoDB database. You can see most of these have been overridden on the right. However, if you have a specific agent, it will have additional things. So you can see here that MQTT is not supported by every single agent. It doesn't need to be. So you need to check from the documentation that what you're actually doing is actually supported. So let's start up a quick system and see what we can do with it. As I said, I'm just bringing up a simple connection of 3 containers, as was shown on the screen a moment ago. You can see it's just getting started. So 4 containers. I've got the my dummy devices as well. Now, as we start up, we're waiting for the context broker to be available, and it now is. If I go into here, I can run my Docker logs file to actually look at the system in question. And you can see I'm already injecting bits of information. Now, I have set up Orion here to say I want to have log level debug, which is the lowest level possible. But I've also set up a couple of additional elements called no cache and log for humans to try and make the debug as easy to understand as possible. Now, this isn't something you would want to do in a production environment, but when you are having problems, it's very useful to get this stuff in without continually caching information or doing additional stuff. So you can see, for example, I'm injecting a load of data here, and it's slowly putting stuff into a database, which is the MongoDB database, and it's finishing its transactions. If you have problems, obviously it will say error rather than info, or it will be quite obvious where the problem actually lies. And we can actually start looking in to what the various error messages are likely to mean later on down the hour. Similarly, as we're provisioning devices, that's Cygnus, the wrong one. Again, I can do my Docker logs here. I can slowly put information into my system here. You can see I'm already putting data into Orion from my devices. So you can see that elements are coming into the system. It says here on the debug, creating initial entity. It's obviously doing an upsert to try and say, I am this device, which has got some information in it. Once again, you will find error messages coming through. An example of the device group not found is that the group doesn't exist yet. It will turn up later on. The level here is perhaps slightly misleading in that a level of error doesn't necessarily mean there is an error. It means it is being logged at an error. So you need to be careful as to what you actually want to find and whether it's going down the various different layers of the group. Similarly, if we go through to Cygnus, once again, you can see that my Cygnus file has been receiving information. So my current setup is quite good. It's actually setting in information, and it's getting data coming through. So how can we provision things? You have provisioned stuff through the base defaults using either your config.js or your Docker environment variables, but you then furthermore need to provision your groups and devices to override further options. If I look at, say, how I would provision a device in, say, MQTT, provision a sensor, first thing I would need to do is create my service group. Now, some of these values would actually exist already in the main config potentially, but this would be setting up additional values. And then if we want to provision a sensor, it would say, for example, the transport for this sensor in this particular case would be MQTT. Now, if your default config is saying it's already MQTT, it doesn't need to have the override. But if the override is missing and it's the wrong way up, then you would potentially have problems. Another point I have seen when failing to get data in is you need to be careful with your mapping variables, in that if you want to map as an integer, make sure you've specifically got it as an integer, because it is possible that it won't be recognised as such, and so on and so forth. So let's see what happens when we actually put some data into our when we get some data flowing into our system. If I go back to my little device screen, and I'll bring my debug up at the bottom as well. So let's see what happens in the IoT agent when I send a command down to ring that bell. I'll make this a little bit clearer by adding a few extra lines. Right. Send that. You can see a lot of debug comes through because I'm actually properly connecting to the system. Where was the thing gone here? So what had happened here was it has received a command saying pending, and it is actually putting out information that I've passed into the system. You can see that it is looking at this service called Open IoT, which was actually set up using the headers of the device when I configured the device. If I look in my MongoDB database, which is where the stuff is being held, which I've got using Compass, you can see that I have got a series of databases here, and the IoT agent is putting its information within a couple of places here for groups and devices for the actual devices, which then gives more information as things such as the service and sub-service. This is the FIWARE service and service path, which is then used. And as you can see, when you look at the Orion, which is also using a MongoDB database, the MongoDB database for Orion, again, is split in two. We've got the standard supermarket store stuff, which is set up without using your headers, which is under Orion. However, we have another Orion database called Orion-Open IoT, which is the name of the service, which actually holds the entities themselves. If you look directly into the entities, and you can see here, all I've done is I'm connecting directly to the MongoDB database on the port that was opened when I set up the Docker file. You can actually see what an actual entity looks like. Now, an actual entity does not look like the IoT, the NGSI response that comes out. It's actually an array of saying, these are my elements, and then each value with the attribute type and the value is set up as an additional part of the attrs, along with any metadata, such as the instant at which it was returned. So you can see that I must be getting data into the system if I have got some entities in Orion. I also must be able to configure the system if I've got some entities with some devices and groups within my agent itself. Okay, now I'm going to send a quick measure, and we'll see what happens with the measure. First, on the device itself, detect motion. Once again, you can see something is coming in, a large amount of debug, and it's saying motion sensor 1 is being updated with this service path, service and service path, with the values. I just set this to 1. Now, you can also look at this in Orion. Get to the bottom again. And it's, I'll send another one to send motion. Send something. Yeah, you can see it's receiving something as a transaction for motion 1, and it's saying where it has received its transaction from as well. So you can see that data is passing in from my device into the IoT agent into Orion. At the moment, I'm not doing anything with my data at all. I've not set up any subscriptions. So if you look at Cygnus, Cygnus has been very, very quiet. It's not doing anything. But what you would find at the top of the Cygnus file is that it would say, okay, I'm configured to do this sort of thing. I can get started. I'm just waiting. I'm just waiting. I'm just waiting. Now, to try and get around that, we would need to set up a subscription and set up a subscription properly. Actually, you can just see there it's just listen to a V1 interface. So let's have a look at that. If you look at the Docker Compose file, each one of these endpoints has got a health check set up for it. The health check is periodically checked to see that whether it's healthy or not. You can see it was up for about a minute, it was healthy. I think I can run that again. Using Docker, I can say, okay, I've been up for 10 minutes, each of my endpoints is healthy. It also rather conveniently tells you which ports you are actually listening on and which ones are currently open. As you can see, I'm currently listening on 4041 for my IoT agent, and it's receiving HTTP traffic from this 7896. But Cygnus here is listening on 5050. These are very useful because if you run the health check, either periodically, and you find that something's fallen over and broken, it's probably because there is some misconfiguration or break in your system, or well, potentially a bug in the source code for all I know. But you will see that you're not running what you're expecting to run. If you're not running something or you're not listening on the right place, then obviously it will not work. So it's a good check to see that it will work. If I go to Postman for a second and close that, and what's it? It's Flume. Most of the health checks I personally use, most of the Docker containers are based on Node Slim, so they actually have curl available within the system. So you can just do a curl command to a well-known endpoint. The usual well-known endpoint I prefer to use is the version endpoint. If I send information to the Cygnus version endpoint, it will give me a version number. Now, this is very, very useful because you need to check that the version you've got is compatible with the other elements in your chain. As you can see from my Docker file, I'm expecting to have Cygnus 110. And you can see that in every single image, I have set a fixed version for the elements. Now, these are based on the elements in the FIWARE release. Periodically, FIWARE does a collection of the various components and gives them a stamp saying that these should work together. So you can check that, is it likely that Cygnus 110 works with the Orion 22? And the answer is yes, it will. It is a very bad idea, unless you are really doing experimental things, to use latest at any time. Latest does not necessarily mean a stable version. It means the bleeding edge tip of things, and therefore is liable to change at any time. You certainly don't want to use latest in a production environment ever. You can see that we have fixed versions for everything in this file, so that we don't have any problems getting into the system. Okay, so having done a check that it's up and running, and you can see that it's going to work, the next thing to do is to obviously make my subscription itself. Now, if I look at the body here is very, very, very broad. Deliberately, the entities and the filtering on this is practically non-existent. If you create a subscription and you want to test it, then the thing to do is to ensure that the first subscription is really broad, and then narrow it later, because you want to make sure that it is firing, and it is firing regularly. You notice again here we have on the notification section, if the system is set up to use NGSI v1, which that particular version of Cygnus was using, it is imperative to have the format legacy. And also you can see that this is saying Cygnus, which is what I'm calling the system within my Docker network, is listening on 50/50. Once again, you can see, hey, Cygnus is listening on 50/50. So you can see that all these things must match up in order for the whole system to work together. So let's send a subscription. And it should give me a created. If it doesn't, then obviously it means my subscription is incorrect. Now, to check these things, you can just run a get on the subscriptions endpoint itself. And it should say what's coming in. It's saying that's the one I had beforehand. And you can see it's been sent once. I'll send it again. It's been sent twice. You can see I'm actually getting data in from my lamps in motion coming in here at a time as the various devices are sending information. So send it again, it should go up to about 10, I think. Yeah, 4 times now. Okay, so you can see that data is coming in. Once again, if you're not getting data in, it means that the issue must lie further down the stack than the receiving component. So it can't be Cygnus that is causing the issue here, because you know that you are receiving subscriptions. As I said, the most likely situation here is that either you would get time sent not going up, which could mean you would have a subscription which is too narrow, or you are not receiving data from your devices. If you want to, you can also use the PM2 tool, which is bundled within the IoT Agents to see what is currently happening. This will give you a log and also give you some idea about what the stress on the system actually is. If I now get it to actually do something a bit more regularly, like switch on the lamp and open the door or something like that, you can see the information is now coming through, and you can see how active the system is going to be. This is a very low active system, but you can see that information can come through. There's more information on PM2 on the internet, trying to find out what could be going on, and you can see how much stress you've got on the system. You can see it's receiving data successfully. Similarly, if you want to see what's actually going on inside your element, whichever one it might be, you can actually do things like bring up a bash terminal inside a running container using a Docker exec. And if I go ls, you can see there's where the various things are, including, as you can see, the config.js. Warning here is that because this is using Node Slim, you might need to temporarily download some additional tools like VI to actually look to see what's actually in there in case you need to make any changes. So, when you are setting debug in your various parts of your FIWARE system, it will vary considerably depending on the components you're using. I'm just showing examples of some of the syntax. The reason behind this is that FIWARE is a open source system which is contributed by multiple different companies, and is based on multiple different technologies. So the actual way to set up debug will depend on what system is being used to get that through. In order to check what's going on, it's always worthwhile looking at the documentation. So when we're debugging, there are various things which we can look at. As I said, we just shown the logs and the PM2 monitoring. Docker PS will just say which elements are running. You can also do things like intermediate listening to MQTT traffic. You have something which is just sniffing on the system, just saying what's coming through. So you can see that data is being posted or data is being received. The other way which you would obviously do things is by, say, sending stuff through Postman. So if I go through at the, where is it gone? IoT agent, yeah. So I can just see if I can, say, ring the bell. I would just be sending a curl request of some sort, which has got some sort of information on there. If I send that, you can hear the bell will go off. If, however, I muck around with it and say send it to some other endpoint, like X, let's say, you can see it's giving me an error, an obvious error message. So you can see that I'm not set up for that particular endpoint. So HTTP is very simple. You can just use curl commands or Postman or whatever to come through. If you're doing something like MQTT or another more constrained protocol, once again, check the documentation. Sanity checks. As I have said at the beforehand, this is my checklist when I'm starting up a system to see, is it likely to work? If it's not one of these, it's going to be something a little bit more difficult. Always specify a version of the product and check the versioning, and use things like the curl to come through, and wide patterns on the subscriptions. When you receive a notification, you can find out time sent, when it was received, things like that, which are rather useful to try and track down what's causing your problem. There are various elements making sure that NGSI v2 or you're going to change it, things are actually set in your system. You can check that using things like, say, Kitematic or something like that to check what your current environment settings are. Okay, so you've got a system here which is still not working for you, and you've looked at the debug and it's still not working for you. And what you're probably lacking now is that you are thinking, I wish I could amend the code in the system to be able to give me the debug I want. And the answer for that is yes, you can do that, because this is all open source software, so you can add in additional lines of debug wherever you like. If I quickly look at the IoT agent, for example, we have here, there's a Docker file for the IoT agent, and it will say what the common information are, but you can also build your own IoT agent. It is possible to clone the source code, make a change, and either build direct from source or build from your own fork of the system. If it's not working for you and there is an issue, then by all means raise an issue and make a pull request and improve the software. We are open to entries from the community. If you have a look at the actual Docker file you would get within this system, again, it's annotated as you'd expect, but you can also modify it just to download the code, just to make a Dockerized environment from the local source code. In other words, use a copy rather than get it from a stable source branch. And you can see actually the actual work being done within Docker is fairly minimal, which makes life a lot easier to work out what you're doing. So you've put in your done your sanity checks, you've added in your debug, it's still not working for you. What should you do next? Well, what you should have done at the top is read the documentation. The documentation is all linked directly from the FIWARE catalog, and you can find the source code as submodules under the FIWARE on GitHub. As I said, these are all independent teams behind the various enablers. If you have a problem there, which is a technical problem, it may make sense to raise issues within individual enablers. However, the usual place for putting in development questions would be normally on Stack Overflow. These are usually flagged within the README of the enabling question, saying where we would actually accept stuff. If you are using Stack Overflow is a third-party site, so it is necessary to follow their rules of engagement. So it's just development questions only. It's not information about, I don't know, pricing or accelerator programs or whatever. It must be a development issue, and you must try to show what you have done and why it's not working. The more information you can put into the system, the easier it is for people to pick this up and explain what's going on. If you ensure that you put the FIWARE tag on there, plus additional relevant tags like, say, FIWARE Orion or IoT or what have you, then it's more likely to be picked up by the relevant team in question, who would then hopefully be able to help you. And if you have a question which is not suitable for Stack Overflow, and there are plenty, or Stack Overflow is sometimes has a reputation of being a bit intimidating. For example, Stack Overflow likes stuff being in very good English. Then there are alternative ways we can do it using the FIWARE Q&A system, which you ask FIWARE, and you can also ask other non-developmental questions under the FIWARE Ask. In summary, try to avoid all simple problems by at least running basic sanity checks first. And you can check each link in the chain by looking at the debug to see that information is coming in, and then look at the error messages if you're having problems. Setting up debug, which is done within the tutorial examples, is always at a far too high level for production. But you should try and set up debug for each component of the chain and check the documentation for details. Your IoT agents can be set up and overridden in various different levels, and this is one of the problems people have when trying to work out how to connect these things. You've got your base config, you could inject a config, or you could add in Docker environment variables, and of course you can do the specific provisioning. The information is all available in much more detail for each individual element on Read the Docs, and you're encouraged to look at the documentation before raising any other issues. But if you're still having problems, you can add diagnostic debug or ask on various different systems. So that is our short introduction to how to debug our IoT agents. I would like to thank you for your time, and I hope you have a good rest of your day. Bye.